Les informamos que al finalizar el mismo pueden visitar nuestra exposición Mujeres en Vanguardia, que estará abierta en el pabellón central, transatlántico, disculpa. Gracias.
Buenas tardes a todos. Vamos a la siguiente conferencia que vamos a presentar. Pertenece al ciclo de Matemáticas en la Residencia, que, como ustedes sabrán, se organiza conjuntamente por la Residencia de Estudiantes, a la que agradezco pues, todas las atenciones que han tenido durante este periodo, el Instituto de Ciencias Matemáticas y también la Vicepresidencia Adjunta de Cultura Científica del CSIC. Lo organizamos entre los tres juntos. La idea es un poco llevar también las matemáticas a un lugar emblemático de la cultura como es la Residencia de Estudiantes. Este es el objetivo y con ese objetivo estamos trayendo a algunos de los mejores divulgadores de las matemáticas del mundo. Ya han pasado por aquí, ya llevamos varios años haciendo esta actividad. Normalmente programamos 2 conferencias por año. Hoy, en este caso, pues seguimos esa estela de mantener a grandes divulgadores de las matemáticas en temas que yo creo que son muy atractivos para un público general. En este caso contamos con un matemático bastante conocido, Florin Diacu, aparte de ser amigo mío, que es un profesor de matemáticas de la Universidad de Victoria, en Canadá. Obtuvo su título de doctor en la Universidad de Heidelberg, en Alemania, en 1989, perdón. 89, te he puesto más años. Obtuvo también un premio muy prestigioso en sistemas dinámicos, que es el J.D. Crawford Premio, en el tema de su investigación, porque es un investigador bastante consolidado e importante en el problema de los n-cuerpos, que es uno de los grandes problemas de las matemáticas, más estudiados durante siglos, sobre todo en espacios con curvatura, es su especialidad. Además, es también vicepresidente de la Sociedad Matemática Canadiense. Así, por tanto, sus temas, como os he dicho antes, son el estudio de los problemas de los n-cuerpos. Por ejemplo, podemos pensar en el estudio del movimiento en el sistema solar. La especialidad suya está a caballo entre muchas áreas de las matemáticas, todas realmente importantes, como son sistemas dinámicos, mecánica celeste, física matemática. Y además, Florin Diacu es un apasionado, el profesor Florin Diacu es un apasionado también de la historia, y en este sentido la historia de las matemáticas es uno de los temas que pues, quizá nos va a ilustrar hoy en su conferencia. Ha escrito muchísimos artículos de investigación, no vamos a entrar en ellos ahora porque no es el motivo de la conferencia, pero también es un extraordinario divulgador de las matemáticas y de la historia de las matemáticas. Ha escrito algunos libros que son auténticos bestsellers mundiales. Por ejemplo, escribió un libro sobre megadesastres, la ciencia que predice las futuras catástrofes, las nuevas catástrofes, que es un bestseller que se ha traducido a distintos idiomas, creo chino, japonés, etc. Y también otro libro, que yo creo que va a ser el tema del que va a tratar en la conferencia el profesor Diacu, que va a ser el milenio perdido, la cronología histórica en cuestión, ¿no? Ese es el tema que yo creo que se va a abordar hoy. Las bases científicas en que se basa la cronología histórica. Nos va a explicar un poco en qué se basó, dónde está la historia de este tipo de cronología, si es correcta, ¿no? Por eso aparece ese título tan provocativo. ¿Realmente estamos en el año 2015 o es quizá mucho más atrás o no? Bueno, pues yo creo que desde el método científico Florin Diacu va a abordar esta cuestión desde ese punto de vista y, bueno, pues pondrá en tela de juicio algunas de la cronología actual o por lo menos nos dará que pensar, que yo creo que es lo importante, ¿no? Puede ser cierto, puede no ser cierto, pero nos dirá cuál es la base científica de todo este tipo de cosas y donde jugará un papel realmente interesante las matemáticas. No sabemos, entonces, esperemos que hoy nos diga el profesor Diacu si realmente estamos viviendo en el año 2015 o si atendemos a los debates electorales y al nivel de esos debates electorales, quizá estemos en la Edad Media, no lo sabemos, pero yo creo que es un poco la idea que tiene el profesor Florin Diacu hoy para explicarnos y, sobre todo, lo importante de este ciclo, cómo la ciencia puede ayudarnos a entender esta cuestión tan importante. Así que le agradezco a Florin Diacu el haber aceptado la invitación. Muchas gracias, Florin.
Muchas gracias, David. Well, I will speak I could try to speak in Spanish, but I would have, to prepare quite heavily such a talk. And I would deprive you of the possibility of, new ideas coming to me and saying them loud. So I will talk in English. First of all, let me say that I feel very honored to be here. I like Spain very much, and especially Madrid. So that's a different aspect. But being here at this place, which is imbued with so much culture and so many important people have been here, I feel very humbled about this. Okay, so this is the title. I've had the opportunity to give this conference in many places all over the world. I've had only in seminars, for instance, where you had 30 or 40 people. But I've had also once at the University of Toronto, I had a full room of 400 people that attended a conference on this subject. So it's intriguing, of course. And I was also curious about these things. I learned about them, and I describe in my book, In the Lost Millennium, which David mentioned. Here I will show it to you at the end on a slide. I came to study these things because I heard that a Russian mathematician uses mathematical methods to study historical chronology, and he thinks that we're not quite right. The historians are not right. And this sounded to me like impossible initially. And then I started reading about these things and doing my research as well, and in the end I wrote this book. And since then, I get asked all the time about this topic. So, the dates we learn in history were not always there. Actually, historical chronology as we know it today, is due to this man here. Here is a picture that exists today at the University of Leiden in Holland. It's Joseph Justus Scaliger, or Scaliger if you want, because he was French. And he was a philologist, mastered, I shouldn't say speak, but mastered 13 languages, because many of them were dead at the time. So this fact allowed him to read documents in all these languages. He was actually interested in how literature and how philological ideas evolved. And for that, he had to find out who lived when. The problem was that all these events in history that existed, people knew about them. Surely, they were in documents, but nobody knew exactly when those things took place. And the reason is very simple. Old documents, they did not use the calendar we have today, the Gregorian calendar. Or even if they used some kind of calendar, actually Scaliger had to study more than 50 calendars, many of them dead, of course, to understand what happens. And I will give you examples immediately such that you get an idea how difficult it was to do that. So he encountered a lot of difficulties to find out, so to put chronology, so to put this on a sound basis. And before him, there existed only local studies, and for finite periods of time. For instance, there were studies for the chronology in the Bible. There was a lot of religious interest, and so people wanted to understand exactly when the people about which stories occur in the Bible lived. He wrote a 7-volume book called De Emendatione Temporum. Of course, he wrote in Latin. And he spent almost all of his life doing this. He didn't get to his original aim at understanding the philological ideas, because this took him practically all his time. He worked for about 40 years on these things. And to today we have a chronology because of him. He encountered a lot of opposition, ferocious opposition, I would say, but somehow he survived. Not exactly in the form he made it initially, but fundamentally with small changes, the dates we have today, we owe them to him. So let me give you some basic concepts about calendars in order to understand what the difficulties are. So first of all, we have the year, the tropical year or solar year if you want, namely the time the Earth goes once around the Sun, is approximately 365 days and almost a quarter, but not exactly a quarter. If it were 25, so 365 days and a quarter, things would be very simple, because then we could solve a calendar just by introducing the leap years we have. However, this is not the case. Then the month, synodic month, is how much it takes the moon to go once around the sun, once around the Earth, I'm sorry. And this is, you see, 29.53, about 29 and a half days. Now, 19 years is close to an integral number of months, namely 235. So you have to multiply 19 by 29, and then you get, so in 19 by 365, and then you get approximately the same number, so a periodic number. Now, because of these problems, there are three basic types of calendars. First of all is the solar calendar, which takes into account the year mainly, and our Gregorian calendar is of this type. Then there are lunar calendars that take into account only the months. And then there are combinations, lunisolar calendars, such that the Hebrew or Jewish, the Chinese, and others. Now, let's look a little bit at the Gregorian calendar we're using. It didn't occur all of a sudden. It occurred from the Julian calendar, which in itself was based on the Roman calendar. The Julian calendar was introduced by Julius Caesar, the well-known Roman, who came up with it in 45 BC, so improved what was until then the Roman calendar. I'll tell you about the Roman calendar as well. So the Julian year, as it was at the time, was exactly 365 days and a quarter. He achieved by having one leap year every 4 years, so to make a correction, but this gives an error of 1 day in 128 years. That's the problem, because of the difference in the numbers I showed you before. So July was named after Julius. August was named then after Emperor Augustus, who made small changes to the calendar after Caesar. And the Julian calendar was canonized in, if we believe the current chronology, was canonized in 325 AD at the First Council of Nicaea. Now, the Roman calendar, on which the Julian calendar was based, was very unreliable. So you see here, much of our knowledge about it is mostly guesswork. And why is that? What is the reason for that? Well, the year started on March 1st, had 10 months, a total of 304 days. And the months were Martius, Aprilis, if we pronounce them in Latin, Maius, Junius, Quintilis, Sextilis, September, October, November, and December. Now, allegedly, in this we don't know for sure, either the king Numa Pompilius, who you see lived 700 years before Christ, introduced February and January in this particular order between December and March, increasing the length of the year to 354 or 355 days. And then apparently in 450 BC, January and February were switched as they are today. The problem, however, was that sometimes an extra month was introduced, and they called them intercalaris. And in an 8-year period, the length of the year could be 355, 377, or 378 days with 12 or 13 months. And there was no real rule of when you came up with the intercalaris. In practice, this was the duty of priests to keep track of the calendars, but for political reasons or because their kings were telling them, or because of bribes, they sometimes made the year longer, some other times they made it shorter. Leap years, they were superstitious and didn't like leap years, so tried to avoid them whenever it was possible. So these are all the reasons why the Roman calendar was unreliable. So then it's very hard to tell something about when events happened when you don't have a regular calendar that you can rely upon. Now, the Islamic calendar, for instance, I told you it is a lunar one, has 12 months and is based just on the moon's motion. So it's 12 times 29 point approximately 53 days, so it has 354 days. So it's shorter by 11 days than the tropical year. Years are counted since the so-called Hijra, which is Muhammad's immigration to Medina, so 622 AD. And so, for instance, the Islamic year 1424 started in 2003 AD, although only 1381 years have passed in our calendar. It's still used today in Saudi Arabia and other Gulf countries. Now, the Jewish calendar is lunisolar, so somehow combines the two. Since 12 months are about 11 days shorter than the tropical year, as you've seen, a leap month is inserted about every third year to keep the calendar in tune with the seasons. So length of the year can be, you see, 353 days, 354, 383, 84, or 85 days. They celebrated 4 New Year's days, but now only 2 are celebrated. And Jewish Day begins not at midnight as we do it, but at sunset or when 3 medium-sized stars are visible. So even in the day there are irregularities, non-periodicity. And years are counted since the creation of the world, which, according to the Old Testament, would be 3761 BC. Now, you see, with all these difficulties, Scaliger tried to find methods of deciding the dates he found in documents. For instance, some documents, some old documents, contained information about the lunar year, the so-called solar year, and the indiction. And what happens here, what is 19, this number, sorry, lunar number, solar number, what are these numbers? So 19 is the smallest integer number of years the moon takes to complete an integer number, approximately an integer number, namely 235 days around the Earth. So this is the smallest number of years. Then 28 is the least number of years after which the calendar repeats itself. In other words, today it's Thursday, the 17th of December. Well, only 28 years ago it happened the same thing, to have a Thursday on, to have the 17th of December on Thursday, and it will happen again in 28 years, but not in any other year in between. And 15 is the Roman indiction, which is a taxation cycle established by Constantine, starting with January 1st, 313. So if a document tells you in what's the difference from these numbers, then you can actually find out when that happened. So this method assigns to every date in history its corresponding Julian count, having its base the Julian epoch, set by Scaliger in 4713 BC. Well, don't ask me why it's this year. I could tell you, but it would be another talk. So let's not get into that detail. It's a quite mathematical talk, and there are several papers, mathematical papers, written about why he chose this particular year and not some other one. Of course, Scaliger was criticized by many, as I told you. He had to, he survived, his chronology survived in spite of ferocious opposition. But among those who criticized him were also many cranks, called it in English. So people who really don't have a reason to make the criticism, just to make themselves perhaps feel important. Now, probably the best known crank, so the best known person who made a lot of waves in the 1950s about this was Immanuel Velikovsky, who wrote two books, one entitled Worlds in Collision and the other one Ages in Chaos. He was actually a Russian Jewish medical doctor. He grew up in the Soviet Union and was a brilliant student. Then moved to Israel, where he practiced medicine, psychiatry. And just before the Second World War, he went to visit the United States, and the war caught him there. So he didn't return to Haifa, because he was based in Haifa in Israel. Established himself in Princeton, had enough money, didn't have to work to find a job, and wrote these books. Actually, he wrote them in the opposite order. First was Ages in Chaos, and then was Worlds in Collision. Ages in Chaos is exactly what it says. So that chronology, he thought, is completely, totally, and absolutely wrong. And then Worlds in Collision was trying to prove why this happens. He couldn't publish the books first. In the end, he succeeded. Well, I must confess, I must tell you, I read them. They're extremely well written. He has a real talent for writing, and you get drawn into what he says. Of course, if you, and he seems very convincing about everything he tells you. Of course, if you go into details, you see that all that is nonsense. And for instance, in Worlds in Collision, he tells that the only way we explain the current orbit of the Earth is by the fact that the comet came very close to the Earth, almost collided with the Earth, with us, and then that comet is now the planet Mars, which then 1,600 years later came again very close to the Earth, and again almost collided. And these things just happened, and for this reason, to prove it, he comes up with documents, citations from all kinds of old books and documents. He has over 1,000 citations, and interprets them the way he wants. He says that at some point the Earth stood still, so stopped rotating. For 10 days, question, well, if it stays, there is no day and night, it's just day. How do you know 10 days passed, right? So you can ask very simple question simply to say that he is wrong. But, you know, I study celestial mechanics, so if somebody comes and tells me something like that, you know, I try to explain to him that, you know, we can do all these computations back, and actually there are people who do these things. We have experts who we can tell you exactly how the planets moved in the past, you know, 50,000, 100,000 years, very precise computations. And of course, there is nothing like that. Well, these were the reasons for which he said that events described could happen only at certain times and not at the times historians told them. Well, he became rich out of these books. He sold millions of copies and then wrote many others. And even today there are people who are followers, and sometimes I still keep getting messages and books these people send me somehow to retract that I said bad things about Velikovsky. Well, I'm sorry, but science is science. I didn't say bad things about him. I said only about what he wrote. I never met him as a person. So this has nothing to do with it. But, of course, apart from the cranks, there are also people who cannot be dismissed easily. And one of them is Isaac Newton. Very few people know, actually, that Isaac Newton spent the last couple of years of his life writing this book, The Chronology of Ancient Kingdoms Amended. He finished it, died very shortly after, and the book was published in 1728, so 1 year after his death. It's interesting, the story how he came to write this book. First of all, he became interested in historical chronology late in life and wrote a short paper, well, 30, 40 pages, something like that, which he circulated among friends. And his idea was that the chronology of Greece, of ancient Greece, in Scaliger's work was wrong by about 300 years. So Scaliger had made it by 300 years longer than it should have been. Somehow this paper got into the hands of a French publisher who translated it into French and sent a letter to Newton asking for permission to publish it in French. And Newton refused. Actually, didn't answer back. And then that publisher tried again. Newton ignored him. And then a few months later, he received the book translated in French, published, and got absolutely mad about it because he didn't want those things to become known. He thought he didn't have them in a form suitable for publishing. So then, to set the record straight, he decided to write this book, The Chronology of Ancient Kingdoms Amended. And actually, I found it in our library at the University of Victoria. It's from that first edition for 1728. And nobody lends you such a book. It's just a special collection, so I had to go and read it in the library and with special surgical gloves, such that not to touch the paper. Of course, a book like this, you don't give it to anybody outside of the library. Again, very interesting book, pretty hard to read, but because Newton comes up with all kinds of arguments. He sees in some places, for instance, that one king was interpreted twice, so was split in two in different periods. That's how he shows that the history of Greece can be short. And then the problem is, because on the history of Greece, a lot of other histories depend, the histories of other regions of Europe. The debate lasted about 100 years after Newton's death, with those who were in favor of what Newton said and others who were against. And this can be traced very well, and I traced these things in my book. In the end, things died down, and historians didn't change anything. So the chronology remained as we know it from Scaliger. Then another important person who talked against the traditional chronology was Nikolai Morozov, a Russian polymath. Rarely you can see people who did so many things in so many fields. When he was young, he plotted against the Tsar, wanted to, with others, revolutionaries, wanted to get rid of the Tsar. Their attack didn't succeed. They were all arrested, and many other intellectuals were arrested. And he spent 27 years in jail for this, near St. Petersburg. However, those years were for him very useful, because in that jail, there were only intellectuals. University professors, researchers, and so on, all people who tried to, to get rid of the Tsar. So they started lecturing to each other, giving lectures, like this one I'm giving to you. But then, you imagine, in this room are people in the various fields, so everybody knows something, everybody is an expert in something. So there in jail, he got to learn a lot of things and started publishing. He started publishing in mathematics, in physics, in chemistry, in biology. Started translating books from English into Russian. The Time Machine, for instance, it's his translation by Wells. Got involved in the Mendeleev's table of elements and so on. And when he came out from jail, he started writing about chronology and looked at various things related to chronology. Some of them I'll mention further here. So, for instance, one myth we all know about is that Chinese history is older than, so Chinese culture is by a lot older than the European culture. Actually, Chinese chronology was reconstructed later, was based on Scaliger's chronology, and Scaliger did it just for Europe and the Middle East. He didn't go as far as China or India. Of course, not talking about America, I mean, very little was known about America at the time, at his time. But Morozov looked at the Chinese history and said that it's by far shorter than believed. His argument was a misapprehension of the Saturn-Jupiter cycle, namely, it's a 60-year cycle. In a 60 years, Saturn makes about 2 rotations, and Jupiter makes 5 rotations around the Sun. So about 60 years later, they come to the same spot they've been before. Now, he said that the starting point of the cycle, well, you can start it everywhere, but the Chinese initially said that it was in the 3rd millennium BC, but he said no, it should have been in 1323 AD. So he just eliminated 4,000 years from Chinese history. This is an absolutely outrageous claim. His evidence, he said, was the starting point of the cycle took place during the reign of a Chinese emperor. It was actually the first Chinese emperor. But his astronomers recorded an alignment of all visible planets near the stars Alpha and Beta of the constellation Pegasus. So constellations, stars in each constellation, Alpha is the most luminous star in the constellation. So Alpha and Beta are then the first and second star in that constellation. So with this claim, he practically eliminated so many years from, because nobody took him seriously about this claim. However, if we look at what historians say, here is a highly respected historian, British historian, Sir Herbert Butterfield, former Regius Professor at Cambridge. In his book, The Origins of History, he wrote that the cataclysms of Chinese history seem to have spared little of the historical writings of the pre-Confucian days, namely before 550 BC. Remember, the first Chinese emperor was 2500 BC. And from early times, there seems to have been controversy about the genuineness of the textual accuracy of the things that did survive. Now, one thing he ordered, this Chinese emperor, what is known, is that when he came, he ordered everything to be destroyed, all the writings to be destroyed, because he wanted to be the first. Nobody was before him, and it was a barbarian act against culture. So, indeed, we know very little from the ancient times about the Chinese history, and just the reconstruction that exists today seems to be pretty shaky given the circumstances. And finally, in my talk shows up Anatoly Fomenko. This is a picture when he was much younger. He's now in his 60s. I never met him personally, though we corresponded quite a bit. And recently, I mean, he knows that from my book, of course, he knows that I highly respect him as a mathematician. He's a member of the Soviet, was a member of the Soviet, now of the Russian Academy of Sciences. But about his historical work, it comes quite clear from my book that he has done very interesting things. However, he has done things that are pretty shaky themselves. However, he, last year, I published an article in the bulletin of the American Mathematical Society about, notices of the American Mathematical Society about mathematical methods used in the study of chronology. And he was very happy to write to me back and to thank me that I did that, although I was not very laudatory about him in that, but somehow he liked the fact that these things become known, that he becomes known, even if not necessarily positively always. So, Fomenko followed Morozov, read Morozov's books, and got to do research by himself. And he was not only criticizing the chronology of Scaliger, but he came up with his own chronology. So here is what it looks like. Now, this is a table from his book. Now, to understand it, you have to know that when he puts, for instance, K here, means that this historical period you see here is from 1700 BC to 1700 AD. So here is about year zero. Well, there is no year zero. Year one, right? So, for instance, K means that this sequence was repeatedly, the same events were put 3 different times. Or this triangle here, this triangle, these triangles were, the same events were repeated several times. How can they be repeated? Well, he says, individuals can be known under different names. Well, sure. Especially in older times when there was less communication than today, you can accept that. The same is true about cities, right? If you think, let me give you a simple example, say Milano in Italy is known as Mailand in Germany, or Bratislava in Slovakia is known as Pressburg. It doesn't even sound like this in Germany and in Austria. Even my own native city, I was born in Romania, in the city of Sibiu. The Germans call it Hermannstadt. So, yeah, that's plausible. He even claims to have found dynasties that overlap. He looked at each individual in a dynasty. Of course, the names are different. the periods are different in history, but he looks at sequences and says, okay, this dynasty says for instance, has 7 names in order, and then how many years each person reigned. And he says, okay, if you look at this dynasty from ancient times, look at this dynasty from, say, Europe, medieval Europe, and you see that they have the same sequences. No? I looked into this in my book, and it just doesn't hold water. You know, it's not, and of course, without this, it's very hard to claim that without these sequences that that repeat themselves, you have so many events, you cannot put them into so few years, because he claims that history is by about 1,000 years shorter, so goes much beyond what Newton said, not 300 years for Greece history, but it says the entire history was made by about 1,000 years too long. So in other words, Jesus Christ was not 2,000 years ago, but 1,000 years ago. Okay, so let's see on what he bases all these things. Now, one thing that Scaliger did was, so the way he reconstructed history was a very smart and intelligent methodology. He first put some landmarks. Years he thought, events for which he thought he could date them precisely. How? Well, perhaps the date was in the document, at the date he could compute, or using a clock. What clock do we have in history? Well, it's astronomy, astronomical events. We can compute very precisely when astronomical events took place. For instance, the history of the Peloponnesian War by the Greek historian Thucydides describes a sequence of 3 eclipses. And Scaliger put the first, which was solar, in 431 BC, the second, also solar, in 424 BC, and the third, which was lunar, put it in 413 BC. He describes each event in a sentence or two. He tells how many years passed between them. So such sequences are very rare in history. Now, you see, older Petavius lived just after Scaliger. Then you see here names from other astronomers who computed the total phase. They didn't have the mathematical methods we have today to understand these things. So each one gave a different number for the maximum phase. So here the percentage means how much the sun was covered for the 431 eclipse. Petavius gave, for instance, 85%. Others gave more or less, 91. But here you see only 65. Now, these two astronomers, Stevenson and Fattochi, are contemporaries of ours, and they live in England. And they said that in Athens, the maximum phase was 88% for this first eclipse. Now, let's read the description of this event. That's what Thucydides said. The same summer, at the beginning of a new lunar month, the only time it seems at which it is possible, the sun was eclipsed after midday. You see, we have the time of the day approximately. He said summer, and it took the form of a crescent. Then some stars became visible, and it turned full again. Okay, now we have to understand a bit what Thucydides meant. So first of all, summer. In Greece, at the time, even today, people consider just 2 seasons, summer and winter. So winter are usually December, January, February, and then everything else is summer. Then some stars became visible. This is key here for Fomenko, because stars, has anybody here in the room witnessed a total solar eclipse? Please raise your hands if you have. Nobody has. So you see the one. Okay, so I have two. So we are two people in this room. Three. Okay. They are very rare events. So that's good, because then we can date them more easily. But if it's a total eclipse, if it's not total, if it's very close to total, stars cannot occur, even if it's only 1% of the sun visible. So this, I showed you the figures before. All these astronomers said that first eclipse could not be total, and if we are to believe Thucydides, then it must have been total. So something is wrong with the first eclipse. Of course, historians, what would they tell you? No, we have to ignore this. Okay. It was set in 431 BC, it was 431 BC, so in fact, in history, you have to ignore things. You have to accept certain things and to ignore others. Because if you don't, you'll have contradictions all the time. So the problem is, what do you accept and what do you ignore? That's always a problem. Okay, so now let's see. According to Stevenson and Fatohi, in Athens, I told you it was 88%, but the maximum phase was 98%. And the eclipse was annular, meaning the moon came exactly in the middle of the sun, so the sun looked like a very thin ring, like a circle, if you want. And here's the Black Sea, here is the Peloponnese, here is Turkey today, right here is Crete. So this was the region where the phase was maximum. Well, Peloponnese is here, so it could not have been in that area, so more than 2% of the sun was visible. So it could have been probably, you see, in Athens was 88, so 12% of the sun was visible. So no chance to see stars, definitely. Okay, Morozov and Fomenko came up with two new solutions. Morozov showed that this was a possible solution, AD 1133, 1140, and 1151 for the three eclipses. And Fomenko came up with this one and showed that there are no others. In the whole history, these are actually the only possible ones for which you have here a total solar eclipse, and here as well. Well, that's about 1,500 years. Right. Wrong. Okay, so let's look at other things related to this eclipse. In chapter 23 of book 1, Thucydides wrote that during the war, eclipses of the sun occurred with a frequency unrecorded in previous history. Well, do we believe him? Well, this is a statistical statement. It's not a very precise statement. Yeah, so it tells us that many more. Well, with statistics, is less possible to make mistakes. So let's look at the eclipses. Now, let's see the frequency of eclipses before and during the war. So you see, this was August 3rd, 431, November, and so on. You see, were these actually eight eclipses, all of them partial eclipses. Remember, Thucydides described only two of them. Now, during, as I said, 8 eclipses, if we believe that, half a century before were 16 eclipses. So that's comparable. So you cannot say that there were more during the war. Yeah? If 50 years were 16 and in 27 years were 8, it's about the same number during the war. That's for the classical solution of Scaliger. Now for Morozov's solution, for these two areas of comparison, he has 7 to 15. So 7 during the war, 15 50 years before. And Fomenko solutions, 11 during the war and 15 before. Actually, I wrote to Fomenko when I figured out this, and he was very happy about it. He congratulated me. Well, I said, at the time my book was not finished. Well, I said, well, you probably won't like other things I wrote. But about this, he was very happy, because he said, well, my solution is probably the right one, according to this statement. Okay, so should we believe that or not? It's fully up to you. I don't have an answer to that. Just think about that. Okay, let's look at other things. An important historical event was the Council of Nicaea, and as I told you before, historians put it at 325 AD. Now, on that date depended actually the change and the occurrence, if you want, the birth of the Gregorian calendar. Because relative to that date, the astronomers who who advised Pope Gregory XIII to change the calendar, decided that 10 days must be cut. So let's see at the papal bull given on the 24th of February 1582, let's see what it says, and then let's see whether things were correct about the 10 days to be cut or not. Because Fomenko and his collaborator Nosowski claimed that that was a wrong number, was a mistake to do that. Okay, so let's see. Our care was not only to reinstate the equinox in its long ago nominated place, from which it has deviated since the Council of Nicaea by approximately 10 days, and to return the 14th moon, which means the full moon, to its place, from which it has deviated by 4 and 5 days, but also to settle such modes and rules according to which future equinoxes and the 14th moon would never move off their places. Now, we would like to have the Easter approximately at the same time, same with Christmas. Therefore, to return the equinox to its proper place, established by the Church Fathers of the Council of Nicaea on the 12th day before the April calends, which means March 21st, we prescribe an order relative to October of the current year, 1582, that 10 days from the 3rd day before Nonas, October 5th, to the eve of the Ides, October 14th, inclusive, be deleted. Okay. Now, Nosowski noticed 2 errors, so a collaborator of Fomenko noticed 2 errors in the papal bull. First, the time difference between spring equinox and full moon is claimed to keep constant in the future, but this is not possible, because the cycle of full moons and the date of the equinox shift at different rates. Now, but this is a minor error. An error that is important, however, has to do with determining the equinox and the full moon, which are connected to the date of the Council of Nicaea, namely, what I told you before, 325 AD, on which the correction of the calendar depends. And let's see why they think that this is wrong. First of all, let us understand that the Christian calendar consists of 2 parts, a rigid part and a flexible part. The former, the rigid part, is the old-style solar Julian system, about which I told you before, with its fixed celebrations, like Christmas. It's a fixed celebration, it's always the same day of the year. Whereas the latter is the lunar Easter book, which determines the variable Christian feasts and festivals. Now, you know that we can compute the date of Easter. It varies all the time. Gauss, the famous mathematician Gauss, has a formula which is very easy to apply. I remember when I was a child, I got that formula, and then I started computing the dates and told my relatives who were living in a village about that, and they considered me a genius. Actually, I was no genius. It was very easy to do some easy arithmetic computations, just they didn't have the formula. Because then whenever the calendar, the church calendar came out and they saw the date of Easter, they said, Florin told us that he knew that. Okay, so this is the Easter book, which helps you with the computations. Now, let's look at another document. And Nosowski looked at this document of Matthew Vlaster, who was a chronicler, and he wrote in 1330 that the rule on Easter has two restrictions: not to celebrate together with the Israelites and to celebrate after the spring equinox. Two more were added by necessity: to have the festival after the very first full moon after the equinox, and not on any day but on the first Sunday after the full moon. So four rules. All the restrictions, except the last one, have been kept firmly until now. But now we often change for later Sunday. We always count 2 days after the Passover, so after the full moon, and then turn to the following Sunday. This happened not by ignorance or inability of the church fathers who confirmed the rules, but because of the lunar motion. Okay, so he sees here a correction of 2 days. Remember, this was 1330. Well, so the error Vlaster noticed is 2 days, as I just read. But the difference between the real full moon and the one in the Easter book is 24 hours in 304 years. So this is the error that accumulates. Yeah? Every 304 years, you make a mistake of 24 hours. So then, if we agree that Vlaster wrote this in 1330, then the Eastern book must have been written by 722. This means 1330 minus 2 times 304, right? Now, with the Easter formula by Gauss, which I told you about, Nosowski calculated the Julian dates of all spring full moons from the 1st century AD up to his own time, and compared them with the Easter dates obtained from the Easter book. He reached a surprising conclusion. 3 of the 4 conditions imposed by the Council of Nicaea were violated until 784. How is it possible? You set the rules in 325 and then you violate them until 784. Well, another reason to doubt the validity of 325 is that the Orthodox Easter dates repeat themselves every 532 years. The last cycle started in 1941. The previous ones were 1409, 1940, 877, 1408, and 345 to 876. This is very strange. You hold the Council of Nicaea in 325, but then you start the cycle only 20 years later. Doesn't make any sense. Right? Well, Nosowski thinks that the Council of Nicaea had taken place either in 876 or in 877. The latter being the starting year of the first Easter cycle after 784, when the Easter book was probably compiled. The tradition says this, that the Easter book was canonized in 325, but it had been compiled about 100 years before. So it took a while until Christianity, so religion was recognized by Constantine. So this conclusion agreed with his calculations, which showed that the real and the computed full moon occurred within 1 day only between AD 700 and 1000. From 1000 on, the real full moons occurred more than 24 hours after the computed ones, whereas before 700 the order was reversed. So, according to Nosowski, this should be the correct dates for the Council of Nicaea. So here is a mistake of about 400 years, 500 years, right? 877, so more than 500 years. Okay, let's look at another event. 22nd of December AD 1968. This Leo Diaconis was a chronicler, contemporary with, so he lived at this time, so he was talking about something that happened in the recent past. So he said, when the emperor was waging war in Syria, so he talks about the Byzantine emperor, of course. When the emperor was waging war in Syria, at the winter solstice, there was an eclipse of the sun such as has never happened apart from that which was brought on the earth at the passion of our Lord on account of the folly of the Jews. The eclipse was such a spectacle. It occurred on the 22nd day of December, at the 4th hour of the day, the air being calm. Darkness fell upon the earth, and all the brighter stars revealed themselves. Everyone could see the disk of the sun without brightness, deprived of light, and a certain dull and feeble glow, like a narrow headband, shining around the extreme parts of the edge of the disk. Very beautiful description. Well, the problem with it is the following. He says at the winter solstice, and he says at the 22nd day of December. Well, but this was 968. If this is correct, it couldn't be both at the same time because there was a deviation. There should have been in 968, no, from 325, there should have been a deviation of 5 days between the two. If 325 is correct, and we deleted 10 days in 1582, right? More than 5 days, 5 or 6 days should have been the error. Now, another reason to believe it is that in that area of the world, December eclipses are very, very rare, and we know that it was one on the 22nd of December 1968. The other solutions would be hundreds of years away, and at this time, the Byzantine Empire was still strong enough to wage war. Later couldn't have done it. You know, it disappeared in the 1400s. The Turks conquered it. So, again, we have a problem here. Now, some good aspects of Fomenko's work are the following. The Almagest is a very important astronomy book from ancient times. If you want, it's the same for astronomy as Euclid's book is for mathematics, for geometry. The name Almagest comes from Arab, and it means the great one, in the sense of the great treatise. It was written by Ptolemy, Claudius Ptolemy, who was one of the foremost astronomers of ancient times, and it was written, according to tradition, by about 150 AD. Okay, so what Fomenko looked at was the acceleration of the moon's elongation, namely the angle between the moon and the sun as viewed from the earth. Now, the dating of the Almagest from looking at the star catalog and the sequence of it is done from the star catalog, a sequence of eclipses, and the sequence of occultations. Occultation is the same as an eclipse, but it happens between a planet and a star. So when a planet covers or almost covers a star, then you call that an occultation. Now, doing this study from the Almagest, from the catalogs of the Almagest, Fomenko said that the Almagest must have been written sometime between 600 AD and 1300 AD, not in 150 AD as claimed by standard. And the reason is this curve here. This is from those historical eclipses that occur there and occultations and so on. This acceleration should have given a curve which is like this, constant. So here this curve should not have occurred. But Fomenko putting his chronology into place, this becomes the straight line, as it should be. Okay, so now the highest probability, he claimed it around 800 AD, and for the computed the probability, so this is the highest probable interval, and probably here somewhere, so somewhere in the middle. The rest simply doesn't work. This looking at this star catalog and the other astronomical events. Okay, so now, of course, you cannot end this without talking a little bit about scientific methods, because today we have, you'll say, we have radiocarbon dating, we have dendrochronology, trees, right? We have so-called thermoluminescence, fission tracking, archaeomagnetic dating, paleography. There are many other scientific methods based on physics, based on chemistry, based on biology, which we can use today. And historians do use them. They use them, but the problem is they consider chronology as something given. And then when they find a date, or find a piece of something that can be, say, radiocarbon dated, they do the radiocarboning for it. If the date fits with chronology, they say it loud everywhere. If it doesn't, they ignore it. So, of course, I fully understand that it's very difficult to give up hundreds of years of work, namely the existing historical chronology, and I personally doubt that Fomenko is right, that we miss 1,000 years or so. But that's one thing, and there is another thing, whether we accept the dates from the distant past. There is no problem with the past 500-600 years. Those are fine for sure. The problem, if exists if we go farther back in time. And the farther we go back in time, we may have problems, serious problems with the dates we have, especially, as I say, for the ancient dates. Then many people ask me, why is this important? Why would I care whether we live in the year 2000 or in the year 1000? Well, then I tell them, look, beyond the fact that, sure, we'd like to know what happened in the past, the problem is not that dates are shifted. The problem would be that the understanding of history is wrong in the sense that we don't put the people in the right place. So we might interpret events which actually took place the other way around, and not event A influenced event B, but the other way. Event B influenced event A, and that would be tragic if this is the case. But unfortunately, I don't have the answer for that. All I could do was to present you these things and to let you think about them. Now, this was the first edition of the book. It was published in 2005 with Knopf, Canada, and this is the second edition, which was published by Johns Hopkins University Press in 2011. Unfortunately, they have not been translated into Spanish. They are in other languages, but not in Spanish, so not so far. But if you'd like to know more about these things, I'm sure you can find them and read them. Thank you so much for your attention.
Muchas gracias. ¿Alguno tiene alguna pregunta que hacer al profesor Diacu? ¿Alguna curiosidad que ha quedado pendiente?
Yes, I can hear you. Yes, please use, if somebody asks questions and it's in Spanish, then please use the microphone such that I get it translated. I'll try to understand it, but I might not understand it in Spanish.
Bueno, sí, mi pregunta era, tenemos varias cronologías diferentes, la europea y la china quizás, y si no podemos utilizar estos eventos astronómicos para hacerlas coincidir, u otros eventos astronómicos como supernovas o...
Sure, of course. I mean, this is a very, very good question, actually, chronologists try to assemble them, to put them together. So that's why I'm saying Chinese chronology is fully based on events that happened in Europe as well and in the Middle East. And for instance, to give you an example, there are Chinese writings, chronicles that connect visits of people sent by Emperor Anton. That's all they say, Anton. We can speculate who Anton is, maybe Antoninus Pius, maybe there were several Roman emperors with this name. So 14 times they had these people sent and had contact with the Chinese. So we can relate events that existed between the two. So that's why they try to do this. Now, sure, there is a supernova that was probably at the time of Jesus Christ. We know that, and that supernova was perhaps the same was seen by the Chinese as well. So they try to do these connections as well. Fomenko does that too. So he tells it was not the same supernova, it were different ones, and the same one was. So you see, he's trying to match these things, especially the events that can be computed in time. Now, supernovas, we cannot compute them. They're not something, but eclipses are, or occultations, or these kind of events that are described in history, those we can compute very well. But as I said, now we have so many other scientific methods. Scaliger didn't have them. Scaliger, only thing he could use was astronomy. But now we have so many other things. However, now the chronology is there, and historians don't want to change it. So no matter who tells them how many books are written, they shrug, and we can talk about that. But of course, they have been also unfairly attacked many times by cranks. That's why I'm saying we have to be very careful, because there are so many. You just go to the internet and you'll find so many stupid things on the internet in all fields. You know, everybody can now say whatever they want, and without checking. But yeah, so there are also valid issues, like we have to ask about them. I don't know the answer. We can all think about them and decide for ourselves.
Impresiona la localización del Almagesto en el siglo 800, en el año 800, o las guerras del Peloponeso 1000 años más tarde, o 1500 años más tarde. Claro, en su libro, en su opinión, ¿cuáles son los hechos históricos que peor están datados y más lejos de los datos que el conocimiento, digamos, de la historia ha localizado? Porque, por ejemplo, claro, entiendo yo que en las guerras del Peloponeso hay fuentes griegas y debe haber fuentes persas también, ¿no? Y parece difícil localizarlo en el año 1300 después de Cristo, ¿no? Porque ni siquiera Persia probablemente existía, ¿no? Entonces, ¿cuáles son las distancias, o sea, los hechos históricos en los cuales cree usted que estamos totalmente equivocados?
Well, this is, again, a very good question. And you see, let's distinguish between important historical events, which changed history. An important historical event of this kind, it's 9/11. No. And less important historical events. But then there are important chronological events, which may have not been important for history, like the Peloponnesian War. The Peloponnesian War in itself didn't have much influence in history. But you see, the Peloponnesian War gives us the book is very well written by Thucydides, We understand the life of Greece at the time of the Greek people, and it's very important chronologically. Again, Jesus Christ, for instance, is a huge figure in our culture, but is not an important chronological figure. Why? Because everything that has been written about him is tainted with legend. So it's very hard to distinguish between what is true and what is not true, what is said about him. So then, the important the important chronological events that help us determine are those that can be computed back in time, such as, the Peloponnesian War, or such as the one by Leo Diacu is described there, or, those that give us impressions. You don't have to think that Fomenko is the only one who looked at these things. There were astronomers who looked at, for instance, events in history such as horoscopes. Horoscopes, you think horoscopes, well, nonsense, because they tell you that the next month you'll do this or that, or, zodiacs and so on. No. Well, they are important because they give you the positions of the planets from the chronological point of view. And many astronomers looked at that to see if they can match the horoscopes that we have in documents, many horoscopes. Whether we can match the dates given by history with those that can be computed from the horoscope. Because the positions of the planets, it's again something we can compute easily. So whenever it changes, whenever the planets are in a different constellation, we can know that. Sometimes they stay for days in the same constellation, sometimes for weeks, depends which planets are moving. And it's interesting that Fomenko has also research done on horoscopes, but research has been done by astronomers, and many of those that the astronomers did match with the existing chronology. The problem is that they didn't look at other periods of time, because as I said, they repeat themselves, even like the eclipses, not periodically, but they repeat themselves. So you can have the same configuration of the planets, you have it now, you have it 300 years ago, you have it 712 years ago, and so on. They always looked at those that would match with chronology, astronomers, and they match. They could put them in approximately that period. I wrote that to Fomenko at some point. He never answered back. So these are the events which we can really compute in time. Now, using radiocarbon, using not just radiocarbon, but the other methods as well, any event could be interesting, because it depends what you find. Radiocarbon was pretty bad in the past, and Fomenko doesn't believe in it much, because it doesn't confirm his 1,000-year lost millennium, right? But today, the method is pretty good. It has changed completely. So the difference between the old method, which gave large errors, is, I would use a metaphor here, is the difference as between photography done on film and digital photography. So the method has been completely changed, is much more accurate today, and we can trust it with good approximations.
Bueno, quizás es una impresión mía, o a lo mejor también le ha ocurrido a más gente, que es que ahora mismo tengo la sensación de no saber nada de mi pasado. Y bueno, obviamente desde los hechos históricos, pero es que también ocurre que... Bueno, hablo alto. Que también ocurre...
Well, sure. when I usually, people ask me to sign the book, sometimes they buy the book and then they meet me and they ask me to sign the book, or if I give my book to friends or to people I get to know and so on. And it's interesting that, you know, I'm doing the same thing. I usually I sign it with my name and write the date and the place. But then, sure, the place is easy to write, and then I write the date and then I put 2 question marks or 3, because I'm actually not sure. Yeah, you know, I had exactly the same problem as you had, in the sense that this is how I started to look at this problem. And luckily, in my case, you know, I was an expert in celestial mechanics, so it came as a natural extension of my work, beyond my daily research, which I do in mathematics, in this field of mathematics. It came as a natural extension to look at things, very applicable things, that can be used to understand history. And I can tell you that it was a very, very interesting experience I had. I'm not doing this anymore now. I'm just talking about it from time to time, like today. But I'm not, my interests are not into this problem anymore. However, I was quite preoccupied about them at the time, and I learned a lot of new things. So can you.
Lo que quería preguntar en realidad era que todos los acontecimientos científicos entonces están puestos en un interrogante, y no debemos olvidar que los descubrimientos científicos se hacen desde los conocimientos previos. Entonces, ahora mismo es que no sé si ha sido impresión mía solo, pero nada está claro, ni los cálculos que aritméticamente estoy segura de que están correctamente, pero ni los cálculos a las conclusiones que se han llegado tienen una incertidumbre, un error, porque obviamente todo está basado en los conocimientos previos, desde los hechos históricos hasta los descubrimientos científicos.
You're perfectly right. Actually, what happens is, you see, as a mathematician, you're not a mathematician, are you? You're not. Okay. Euclid, in geometry, came with the idea of axioms. An axiom is something that you start from, which you accept as true, as correct, and then from there you build, you prove, you reduce everything to those axioms. Now, a couple of 100 years ago, we changed one axiom in Euclid's system of axioms. Well, and we understood that axiom, if we change it, we create a completely new geometry, which looks totally different from the previous one. The same happens in history. That's the problem, actually, because when you base something on landmarks, on axioms, as Scaliger did, but he did the correct thing, how otherwise can you do it? The problem is that if one of those landmarks, or 2 or 3, prove to be wrong, then the entire edifice of history collapses. Because all the interpretation that was done of the documents was done based that you accept those initial axioms. And this was not just Scaliger's work. Scaliger started this. It took other 200 or 300 years until the current chronology was put in place. So now, what can we do? Start from scratch. If we start with a different set of axioms, we'll get a very different history, because then we'll ignore other things and accept others. So yes, it might be really fiction for what happened a long time ago. It's not fiction for, the past 500-600 years, as I said, are safe. But before that, it is hard to tell how well we know these things. Do we accept that we saw stars, that he saw stars or not? Was that just something he added there? Did he himself see the eclipse? Did he witness it? Where was he when? all these questions have been asked, such that can you ignore this remark of Thucydides or not? In the end, you make a choice. Sure, you try to make a choice that is guided by logic and is guided by, but you don't know for sure. You cannot know for sure. But that's what happens. There is a question there.
Hi, have you tried to make an estimate of timeline? I know it would be horrible to do another estimate, but...
An estimate of what?
Of a new timeline, a new timetable with certain parameters of statistical analysis and with certain error conditions. I don't know.
No, personally, I have not tried that. And I wouldn't even try to do it because, on one hand, I see what I would say is the failure of Fomenko, because he tries to do it by himself with a few other people in a very short amount of time, looking only at certain things. You have to think that historians, many of them have worked on these things for, as I said, for 200 or 300 years, and to get all the details in place. So no, I don't think this is possible to do it just by one person. It's, if somebody wants to do it, then you have to engage people from many directions of work, many experts from history, experts from philology, experts from science, experts from various sciences and so on, to look into these things in more detail. So no, I don't see this as something that can be achieved by one person now. So no, I didn't look into that, and I wouldn't look.
Bueno, si no hay más preguntas, muchísimas gracias al profesor Florin Diacu por esta muy interesante.
Thank you so much. I'm really impressed. I'm very glad that you enjoyed it.
I need to go because I have to take dinner with my daughter.
Okay. So nice to... No, I'm leaving tomorrow morning. I'm leaving tomorrow morning. But,